number 2, finding line of best fit, you could have done this in Desmos or in the calculator. I'm just going to do it in Desmos. So if we were to make a table and put the order pairs in, then type in your y1 tilde mx1 plus e. You will get your line of best fit. It didn't say what to round to, so 3 decimals is fine. Y equals negative 0.423, x plus 3.09 would be what that would round to. If you put more decimals than that, that's great. If you only put 2, you should have at least 3. Questions on that one? If you had this number 3, just put, if you did that number 3, great. And then for number 4, just put same as number 3. If you had this number 3, give an equation that's perpendicular to the given one. So find what this would be. You could do this in Desmos. I'll show you how to do it in Desmos first. So if I graph that line, I could find the slope and the y-intercept of this line. Slope is 2/3, y-intercept is -2. If it's perpendicular, I need a slope that is the negative reciprocal. So you can put anything that has the negative version of 3/2 instead of 2/3. You can put whatever y-intercept you want. But it has to have this slope. Sure. You can put the same one, you can put a different one, you can just leave it. But if you were doing it algebraically, you would have had to solve this, figure out what that slope was, which would have been 2/3, and then take that slope, flip it, and make it negative. And give some equation. Questions on that one? And then 5. So this one, you could have just used the points that were given. So we had 2, 0, and 3, 2. From this, I can tell the slope is 2. And if I go backwards, I can find what my y-intercept is. And my equation would be y equals 2x minus 2. If you had done that in Desmos, you could have used your y equals mx plus b, made them sliders, put in the points, but then you would have had to adjust the m and the b.
Wait, how did you go from uniform?
I went backwards. I just used the slope and went backwards. Okay. So I would show you that one in Desmos, but time-wise, we're just going to move on. So for the SOL A1, I'm going to show you all the answers. If you have questions, we can go through any of those or go through them in Desmos. If you don't have your packet, I don't have any extras, so write them down on a piece of paper. I'm going to go through this kind of fast. If you don't have the correct answer, just write it down and then you can fix it later. This is really a study guide for you to use when we get closer to the SOL. So number 1 was 7, 2, -7, 3, 576. 4, 33, 5, negative 19, 6, negative 28, 7, negative 10, 8, 13.
Interesting.
Questions on any of those 8 before we keep going? The evaluating piece, you were just putting the x and the y, or whatever the variables were, into wherever the problem was, and calculating, figuring out what that is. Number 9, the answer should have been D. A was close, but the 1/4 times the cube root of x less 5, all of that, the cube root of x and less 5, all of it would have been underneath the cube root instead of it being outside. So D was the correct answer for that one. And then for 10 through 15, you should have had an actual algebraic expression, but for the other ones, you would have been writing it out in words, and those can be different. But 10 should have been the square root of x over 5. Notice where I'm putting my parentheses in the words to show what goes together. The cube root of the product of x and y less 12. The sum of the square root of 16 and the product of 4 and the cube root of 8. This part was unnecessary. I was just showing you what it would have been since we could simplify it. 4 times the cube root, 4 times the cube of a number is 84. So remember, anytime it says is, it's equals. And again, this could be written different ways. Questions on those 4? Okay. 14, 16 divided by the sum of a number and 4 is 9. Amy is 4 years older than Jose. Together, their ages add up to 100. So really, that one was a 2-part one. You needed 2 separate things. And then 16 and 17, yours doesn't have to be exactly like mine. These are just ways to write them. So for 16, I have 5 times the cube root of the product of 4 and x. That should have been subtracted by the square root of y. And 17, the sum of y and the square root of x. Cube root of x, sorry. But you could have had different things there. Questions on any of those? So translating cannot be done in Desmos. That's something you have to know. But evaluating can be used in Desmos if you put that in Desmos. I don't know if you're even allowed to have a calculator this year, but you will have Desmos, so utilize it. The next sections that are due next week on Tuesday, because I won't see you guys Monday because of the holiday, will be President's Day. 2A, 2B, and 2C. All 3 of those, 2A, 2B, and 2C. It seems like a lot, but it's about the same amount that you just did. Now, 2A and 2B, maybe also 2C, you haven't seen before. So try to put it in Desmos, see if you get an answer. If you don't, okay, you can come to see me and I can work through it with you. Some of that is what we're about to do in the next unit. Some of it is what we're going to do in a couple units. So it's okay if it doesn't look familiar or you don't know how to do it. Try your best. But all of 2A, 2B, and 2C is due next Tuesday. And then today we're going to do graphing and writing. We may have to pick up some of it tomorrow, but that's okay. The steps for this are write the inequality in slope-intercept form. Graph it like normal. And then when we graph it, it has some specific rules. If it has a strictly less than or strictly greater than, we're going to use a dashed line. I'll explain what that means here in a moment. And then if it has less than or equal to or greater than or equal to, you're going to use a solid line. And then because we're also saying these are all the points that could be solutions, we're going to shade it. Because I could put this is a solution, this is a solution, this is a solution, all the decimals, fractions, and whole numbers, and that would be a lot of dots, so instead of putting every single dot, they just shade it. So if it's less than or equal to, you shade below. And then greater than or equal to, you shade above. So let's do some examples. For number 1, this is already in slope-intercept form, so you don't have to worry about changing it. Excuse me. You graph this just like a normal line, starting at the y-intercept of -5. Your slope is 1/3, so up 1 to the right 3 as many times as possible. Then, before you make your line, this is where the dash and the solid come in. If we're looking at the symbol, would this be a dashed line or a solid line?
A dashed line.
A dashed line. You don't have to write this, but if it helps you do that. So if it's a dashed line, or you can make it a dotted line, you're just going to put little dashes, tick marks, in between your dots, and draw arrows at the end. Or you could draw the whole line and erase parts of it. Whichever is easier or better for you. Then, this is a greater than or equal to. Would that be shaded above or below? So, above for greater than. And when you shade, you can color in every square. You can just lazily, you can highlight it as a view. If you're not sure where is above or below, some are easier to see than others. Look at your y-intercept. Draw an up and down arrow. And above would be everything above this line. So all of this.
Does the shading have to be perfect?
No. You see mine. Some. I just have to know that you know which general area it's shading. So.
What if I say?
What did you say?
Oh, no, there.
Then the other part is determining which of these points are solutions. So if it falls in the shaded area, it's a solution. If it doesn't, it's not. So 0, 0, would that be a solution? Yes. 0, -5 falls on the line. We'll come back to that one. 3, -2. Yes. 5, -6.
No.
6, no.
Wait, what?
Oh, hold on here. And then -7, 3. Yes. That one should be. So then for points that fall on the line, if it's a dashed line in general, it's not going to be a solution. And you could check this by putting it back into the original. If I were to put this point in for x and y, we have -5. Makes sense. Okay, this line is greater than 1/3 times 0 minus 5. I don't know why this is that, but okay. Is this a true statement? Is -5 greater than -5? No. So then it wouldn't be true, and that would be a solution. So that's how you could check yourself. If you're not sure, maybe you're trying to see, did I graph this the right way? Pick a point, put it in, see, is it true or not? Questions on how to graph inequalities?
Is it a blue day?
Yes.
Okay. Oh, yeah.
Okay, let's do number 2. Again, this is already in slope-intercept form, so we don't have to worry about that. Go ahead and start at the y-intercept, -1. And then your slope, -2, down 2 to the right 1 as many times as possible. Up 2 to the left 1 as many times as possible. And this is less than or equal to, so that would be dashed or solid. Solid. So the equal to is solid, and that's just a regular line, so connect all of the dots like normal. And then this is less than or equal to, so would that be shaded above or below? Below. So again, if you're not sure, look at your y-intercept, draw an up and down arrow. Below would be underneath or to the left. And then if we check which of these points are solutions, if I put in -3, 6, no, 0, 0,
No.
no, 0, -1 falls on the line, we'll come back to that one. -4, 0,
Yeah.
yes, and 4, -3. So opposite of your dashed lines, if it falls on a solid line, it should be included, it's equal to, so it will be a solution. But we could also do the same thing and double check it. If I were to put in 0, -1, we have -1 is less than or equal to -1. Would that be a true statement? Yes. So that's how you would do it. Question on either of these? Let's go on to the next page. Let's do number 3, and then I'll let you guys choose any you guys want to. So for number 3, we have to get this in slope-intercept form. How should we do that? Subtract 5x. -2y is greater than -5x plus 12. And then divide everything by -2. What happens when we divide?
It switches.
Sign changes. So you remember that here, because if you don't change the sign, you will graph it incorrectly. So y is now less than 5/2x minus 6. So go ahead and graph that. Start at -6. Go up 5 to the right 2. Would this line be dashed or solid?
Dash.
Dash. So you can make longer tick marks here. And then would this be shaded above or below? Below. It is less than.
Thank you.
Below would be underneath or to the right. Someone give me an order pair that would be a solution.
-1 still?
-1, 4. Would that be a solution?
Or the 4 negative.
4, -1 would work. Someone else give me a different solution.
6. Yeah. 6.
Sure, that would work. Someone else give me a different solution.
5 negative.
So you just give them.
2/5.
2, 5.
So I don't think.
Oh, right.
If you make it negative, so 2, -5. Sure.
Oh.
So remember that when naming your order pairs, you're just naming the x, y. Are there any other questions on this page we want to see you go over, have questions about? I will say for these last two, you have to remember your Poilux, and your x will be like when you did it on a number line. Greater than, you're going to go to the right. Less than, you're going to go to the left. The y, it'll either be up or down. So you guys can go ahead and put your calculators and iPads up. Who was the last person I had put calculators away? Oh, sorry, put your iPads. Okay. 3, can you